Hi everyone, this is Praktis Sumatif, paper 2, question number 2. So in this question, we are given the function of the volume of the balloon, which is V equals to 2t cubed plus 5t squared plus 9, whereby the t is representing the time in seconds. So the balloon is filled with the helium gas directly from the tank. So we need to find part A, the rate of change in the volume. By the keyword, the rate of change, we are differentiating the V with respect to T. Okay, therefore, bring down the power to the front and reduce the power by 1. So we have 6t squared plus 10t. So we just found the rate of change in the volume of the balloon. And part B, after 5 seconds, the rate of filling the helium gas from the tank reduce. Okay, instead of 6t squared plus 10t become half t times 3t. So if we were, this is the new rate of change. So this is the original. Okay, so in this case, we have 3 over 2t squared plus 5 over 2t. There are some similarities between the original rate of change in volume and the new rate of change in the volume. Okay, that is both contain two terms with the t squared and t. Okay, after that, we need to find the volume of the helium gas that filled in the balloon during the 6th second. So therefore, the volume, the new volume, okay, we want to find the 6 seconds. So we have to integrate from 5 to 6. Okay, from 5 to 6. Therefore, we got to integrate this one. 3 over 2t squared plus 5 over 2t. But then how is it related to the original volume? So let's look at 3 over 2t squared. How do we get 6t squared? What do? We multiply with 4, right? When we multiply 4, we will get 6t squared. So we shall multiply 4, but over 4, so that we will not change the equation. All right, but the moment we multiply this one in, we will get 1 over 4. Integrate 5 to 6, 6t squared plus 10t dt. Isn't it this one is our original volume? So when we differentiate the original volume, we get 6t squared plus 10t. So when we do the reverse, integrate the 6t squared plus 10t, we get back the original volume. Okay, the original function of volume, that is this one. 2t cubed plus 5t squared plus 9. So this will be the volume from after the 5 seconds. Okay, from second number 5 onwards. Okay, therefore, in order for us to find the volume at the 6th second, so we have to integrate this from 5 to 6. So 1 over 4, 2 times 6 to the power of 3 plus 5 times 6 to the power of 2 plus 9. Okay, and then we got to minus that. The same expression, but this time with the boundary 5, the t value equals to 5. So 2 times 5 to the power of 3 plus 5 times 5 squared plus 9. All right, let's use the calculator. Okay, let's key in the general expression for our volume. That is 2t cubed. So 2t cubed plus 5t squared plus 5t squared plus 9. Okay, let's substitute 6 in. We have 6 to 1. 6 to 1, and then minus Substitute 5 in. We have 384 minus 384. Okay, let's simplify this. We take 621 minus 384, the last answer. Okay, and divide by 4. Divide that by 4. We have 59.25. 59.25 cubic centimeter of helium gas. Okay, that's it for the question number 2.